know you guys are professional derivative takers at this point. Professionals.
Yeah,
I know
absolutely.
that. But I'm going to take the derivative of this function. This is just a pretty simple polynomial, but I'm going to take it in a way that you're familiar with taking the derivative, but I want you to think about it slightly differently. Is that all right?
I think that sounds like fun.
So I'm going to take the derivative of this thing. Now, you're used to just writing y prime or f prime of x, but the derivative of y is really, I mean, I could write all those things, but I'm going to write it as dy dx.
Leibniz's notation.
That's exactly right. But this just means change y over change x. So the derivative of y I'm writing as dy dx. And I'm just going to take the derivative of the rest of the thing.
Yeah.
So you of course, you know the power rule. This is just 12x squared. Now, if you thought of this as the chain rule, it would really be 12x squared times the derivative of x. I could write that as dx, couldn't I?
Oh, so the change of x over the change of x.
I mean, that's really what it is,
Yeah.
just like the derivative of y is the change in y over change in x.
Yeah.
But you know, dx, same thing on top and bottom. What do you think that is, Miss Stewart?
I think that's 1.
That is 1. So, you know, I'm not going to write that if that's okay.
Yeah, I think that's fine.
Think of it as 1, but I really could. I could write it.
You could.
I could. The derivative of this, I'm going to write as 6x. Again, I could write dx, but I'm not going to. It's a chain rule, really, right? And the derivative of x, of course, is 1. I could write dx again, but I shan't. I'm just going to write it like this.
Very nice.
So, I mean, this is nothing new. You're just kind of thinking about it slightly differently. I mean, you're really thinking about the derivative of y is dy dx. And the derivative of x, of course, is dx, but I don't bother to write it. So this is my derivative. I think I'm done. Oh, the derivative of -1, of course, is 0.
It's 0, so it's nothing.
Yeah. So I'm going to do another one now.
Very nice.
All right.
Okay.
So here's where I'm going with this. You knew it was going to be something, right? I mean, that first one was just kind of silly.
That's right. But so now you've got y's all over the place.
Yes. This is called an implicit function. I have my x's and y's all mixed up. But, you know, I can take the derivative exactly as we've been doing it, really.
Sure.
So I'm going to take the derivative of this first term. Now, there happens to be a y here. This is not 3x squared. You're not used to seeing this, I think. Are you?
Yeah, usually we've had the y isolated, and so we've just kind of said dy dx equals, or f prime of x equals.
Those are called explicit functions. This one is implicit.
Because you're not solved for y.
That's exactly right. Very good, Miss Stewart.
I'm getting the hang of it.
So I'm going to take the derivative of this, and just think about the chain rule. Of course, it's just 2 times 3, which is 6. I subtract 1, so it's 6y times the derivative of the inside. Well, the derivative of y is dy dx.
So just the chain rule again, taking the derivative of each piece for the chain rule. Beautiful.
The derivative of the next term is 2 times the derivative of x. Again, it's dx, but I'm not going to write it because dx is 1. So I'm not writing it. Equals the derivative of the next term, 2x, dx. Again, I'm not going to write it. Find the derivative of 6y is 6 dy dx.
Very nice.
So that is the derivative of this function. Now, if I wanted to actually solve for dy dx, I suppose I could do that too, couldn't I?
You could. Then you could say the derivative equals blah, blah, blah.
Let's do that. Let's see if we can actually find dy dx. Well, I have 1, 2, 3, 4 terms here.
Okay.
What if I move everybody with the dy dx to one side?
Sounds good.
So I have 6y dy dx. I'm going to move this guy over, so it's plus 6 dy dx.
Very nice.
I'm going to move this 2 over. That's interesting. I have 6's on one side, 2's on the other side.
That's kind of fun.
Purely a coincidence. 2x, I'm subtracting that 2. Yeah. It doesn't always come out as 6's on one side, 2's on the other side.
All right, I was just going to ask.
Yeah, no. So now what do you think, Miss Stewart?
Well, I can't really combine those, and I want to solve for dy dx. I'm thinking we're going to do some factoring.
Yeah, so maybe I could factor out a dy dx.
I think so, sure.
And what's left there? I have a 6y plus 6 equals 2x minus 2.
Beautiful. Oh, you're almost there.
I'm almost there. Now I just have to divide both sides by 6y plus 6, 6y plus 6.
So, of course, we're wanting to get dy dx by itself.
Get rid of that, and I am left with dy dx, y prime, same thing,
right,
equals 2x minus 2 over 6y plus 6.
Very nice.
2 goes into everything,
I think you could simplify that.
So maybe I'll just pull out a 2 from the top and a 2 from the bottom. Can I do this all in one step? And
I think so, right?
divide out that 2? All
You're just dividing everything by 2.
I am dividing everything by 2. So that's going to give me x minus 1, right? This becomes a 1. And divide these guys by 2. I think that I can do that in my head also. I think that gives me a 3y plus 3.
So the way to kind of officially do that is to factor out a 2 from the numerator, factor out a 2 from the denominator, and then divide those. But I think we can all do that.
Yeah,
that's beautiful. Very nice. So that's the derivative. dy dx equals. So that's going to tell me the slope at any point
of this crazy looking function.
Of this crazy implicit function, but now it's in terms of x and y. So that's new
it's
also.
Interesting. Right.
Fun.
So there you have it.
I like it.